Hi, good evening, everyone, and welcome back. Thank you for joining in today here. This is our final meetup or the final live session of Google Cloud Study Jams, marking the end of this learning journey. Thanks a lot for your enthusiasm, your persistence in keeping up with the program. Without any further ado, let's get going, starting with the session agenda. So, first up, we'll do a brief recap of our previous live session. Next, we will have a quick look into what updates have happened in the past week. Then we'll cover the concepts that revolve around data. So database services, data analytics, AI services, right? Mainly the services that are relevant to the upcoming labs for this week, right? The final week. So a recap. The previous live session was held on October 18th, Wednesday evening. In this session, we learned a few things about cloud networking and operations, things like VPCs, IPs, and firewalls, as well as the different operational suite services like cloud monitoring, logging, cloud trace, and the cloud profiler as well. So besides that, we also had a detailed look at the rewards criteria for the program, along with an overview of the leaderboard that was launched. And lastly, we set a few lab objectives for last week, and I hope all of you are on track with those as well. So let's begin this session with a few updates that have come in. So as informed before, these are the extended deadlines with respect to accessing the course for both GenAI and GCCF. So for GenAI, that's 25th October, that's already passed, and for GCCF, that's 27th October. However, please note that the completion deadlines have not, been changed and will not be changed. It is locked in on October 30th, so there is still time to complete the remaining activities if you haven't. Okay, and the second thing that I want to address is regarding the authorization issue, the authorization blocked error with respect to data prep quick start lab that you see here. And as you can see, it's a required lab. This issue has been resolved and you can perform the lab and get it done now. Also, there are still a few things that you need to get done. So as you know, this lab is in activity 4 as well as activity 8 basically. So it overlaps across these two activities. And if you've noticed, there is a version upgrade for activity 4, but it's not there for activity 8. So if you want, you can either complete this lab under both activity 4 and 8, or you can upgrade activity 4, by which that lab will no longer be considered as required under activity 4, but you'd still have to do it anyway under activity 8. So here's how you can upgrade activity 4. So you navigate to the pathway, the GCCF pathway. You'll see activity 4. You can click on the Learn More button to open the module page. So the activity page will open up, and you'll see there's a ribbon on top that says there's a new version of this course available, as well as a button here in green that says course version upgrade available. So just go ahead and click on that button, and then it should show you a pop-up, a confirmation pop-up. You can click on preview to see how the changes looks like, and then followed by that, you can then click on the upgrade button. So by clicking that, basically the data prep quick start lab will not be not be a required lab anymore. And if suppose you do not see these changes being reflected, so what you can do is just sign out and sign back in into the skill boost platform, and then it should appear correctly. So this is how you can activate. You can upgrade the version of activity 4. So the main thing to remember here is that you will get the badge once you complete any activity, right? So under your skill boost profile page, you will see those badges. Once you get them, they won't go away. So make sure you can see the badges for all the activities that you complete, right? And you can also cross check them from the leaderboard. So the leaderboard gets updated on a daily basis. So you will see the changes getting reflected there as well. Okay. So going forward, so we have we are going to be looking at data today, really. And also I think more than just the data services that we have, like databases, storage services, or even some of the analytics services like BigQuery and all the AI services that are there. My goal today is not necessarily, although we will kind of touch upon the different services that are there, but I want you to understand the bigger picture when it comes to how all these services really come together. Why are they even there in the first place, and what are the biggest challenges that one still needs to address, today. So what are the things that an organization or even you trying to create a particular service need to address before you can get to a state of creating these models and predicting and stuff like that. So Typically, you can say we will be discussing things that fall under data engineering. Okay, so now you would have seen this slide earlier in one of the sessions, which is more about the different services that Google Cloud offers, but especially those around databases and storage. So right from in-memory stores to relational NoSQL and moving towards analytical, up till the files and document-based storage structures that we have on Google Cloud. You can see the variety here, right? That's definitely significant. And even in these individual categories that we have multiple offerings. So, for example, under relational, you can see we have got Cloud SQL as well as Cloud Spanner, right? Each with its own specifications. So, as a start, let's talk about these databases specifically. And by database, again, it's not something that's out of the blue or is not really surprising, that it is basically essential. Any real application today or any serious application today will need to store some kind of data, maybe from its customers, individualized, personalized, whichever kind it may be. Unless they are utilities, I can't really think of any applications that would not involve data in some form or the other. So obviously there is a lot of data of all kinds. So it could be of all it could be in terms of the variety, or it could also be like a lot of data in terms of volume. So let's say you are in a position to choose a database you need. There are multiple databases or services that will meet all of your requirements if you're doing a particular kind of application or you have a certain kind of a requirement. So, for example, look, we've got two relational databases, right? So that you've got here. So you have Cloud SQL as well as Cloud Spanner, or in the NoSQL databases, you've got Firestore and Cloud Big Data, right? So put on the head of an organization, right? The question I have is, if they have to choose a database today, what would be some of the factors that they would be thinking of? Or if you had to recommend someone, suppose I'm your customer and I say, which database should I go with? What could be some of the things that I should consider, right? So just to just to show you, and maybe this is not the full set of factors, but it shows these different kinds of needs or requirements that you the customer or you might have, right? So first we have availability. So think about how much uptime you need. If your app cannot afford to be down for long, you'll want some kind of a database that's good at staying up and running almost all the time, right? Something that will guarantee you availability in some up to some extent. And then we have the factor of multi-region. So if your app serves people all over the world, it's handy to have a database that can smoothly handle data across the different regions or the zones over the globe. So yeah, and then you have got skill set as well. So what's your team good at? If they are experts in a particular kind of a database, it might make sense to stick with that one, right? It will save you from that steep learning curve that will be there for the team, right? And then you have operations. So some database need more babysitting, right, than others. So manage databases on the cloud do a lot of the heavy lifting for you, while others require more hands-on attention. So then there is compatibility, right? Compatibility is almost important is very important in certain scenarios. So for example, does your database play well with your tech stack, right? It's a lot smoother if everything works together, right, without any major hiccups or hindrances. And then again, one of the most crucial is consistency. How picky you are about your data being consistent. Some databases are very strict, while you have some offerings that are very relaxed with regards to consistency. And obviously, you also have to think about cost at some point, right? Money does matter. So different databases come with different price tags, and you want to make sure you're not in some kind of a financial surprise in the future down the road. Then you've got future proofing. So a flexible database might save you from many future proofing based issues. So how well can the database evolve with your app evolving to the changes and the change in the requirements of your customers. So, and then there's also data model. So data model can matter sometimes as well. So you have to choose a database that speaks the same language sort of as your data, whether you're dealing with tables, you're dealing with documents, or something else. Make sure that you have to make sure that it's always a good match, that there is some sort of relation in terms of the structure. And lastly, the standards that are there. So if your database plays by some industry standards, then it will obviously make life easier for your developers and your operations team when you need to work with other systems that also follow the same standard. So when you're picking a database, do consider these factors to make sure that it's the right fit for your project, right? And yeah, so there could be trade-offs between these factors, but then it really depends then in that case upon your specific requirements, what you think is best for your customers. Going forward in Google Cloud or in any other cloud, you always have the options of saying something like, look, give me a virtual machine and I'll download a MySQL or a Postgres and install it myself and I'll run it on my own, right? So that is fine. It may work for small applications, and if you have the skills, it's definitely fine. But moreover, you'll find that as things scale, as the number of users increases, as the variety of data increases, or these things cover across geographies, that there is some limit to what a single instance, okay, a single virtual machine can actually do. So that is why we need managed databases where many of the things are taken care of by the cloud provider itself. So for example, it could be the things like patches, it could be backups, things around scaling, high availability. As long as you just say look, we want to have our instances that are present in these regions or zones, and the data provider will take care of them using these managed databases. So I'm just trying to point out here a lot of things that you may have to do if you are not going to use managed databases over the cloud. So in most organizations, like if they are small, for example, like startups, right? The goal is mainly on the timing of getting a particular product onto the market. So they probably want to focus more on that versus all kinds of other operational overheads, right? So managed databases do make sense in many situations, just like how we have other services like Cloud Run and App Engine, the PAS, the FAAS, which takes care of all these overhead in terms of computation. We have managed database services in terms of storage. So before we go forward to the next thing, just to wanted to summarize what we saw so far. We've seen the different databases, right? What could be some factors before you choose a particular database, and then of course we looked at what the managed databases over the cloud mean, right? And we will be looking into how they work now. So now we're going to be looking at the effect that now that we have data somewhere, but now the question is it enough, right? So is the quantity enough, is the variety enough, right? So how do we take it to the next level sort of? So let's look at the various high level statistics that we have, some numbers basically. And I mean, don't get too serious about these numbers. They are just useful for identifying some general trends. And so yeah, so all the organizations, right, say they want to, as you can see on the left hand side, these all these organizations nowadays, they want to invest in data and AI, and everyone wants to do everything with their own data, right? So they say data is the new oil. And things like it will distinguish themselves from the other organizations, how they will have an edge over their competitors, all these sort of things. Fair enough. But the reality is what you see on the right side. And the reality is that they are struggling due to a variety of reasons. So we will look at 2 to 3 challenges that are typically there. So let's go towards the first challenge. So the first challenge is that data is big enough. It's big and it's multi-format. So there's going to be structured data, there's going to be unstructured data. By unstructured, what I mean is things like videos, images, audio data, basically data that is in a blob form, and you need to figure out from the inside what's going on. So the second point is that some of these things need to happen at real time, right? So all these social media personalizations or any recommendation systems that you get within minutes of your activity, right? And of course, the last point is describes that there isn't just one single database for a particular organization. So database, there could be multiple data centers across the cloud, and even you could also have the on-premise traditional data stores, and in different kinds, in especially in different kinds of data stores, the different workflows or the processes in which these data centers operate could vary. So this basically is the first challenge, that data is big and it is comes in multi-format. And let's look at challenge 2. So the second challenge is that data requires more than just SQL. So SQL will only take you so far, because even to do a SQL command onto whatever system that you are there is that allows you to fire that command, you still have to get the data in a structured format into the application. So there are, and more than that, there are downstream applications, right, that might be needed. For example, your AI team will say, for me to make a model, I need the data from not just one, but 15 different applications that our company has on the web. And I want it all in a centralized single place, sort of, so that my team can start working on it. So downstream or data driven applications are also a big challenge. And of course, the third one is that, your data needs to reach everyone. So it needs to reach out to every single user that is there. So by that, typically what we are trying to say is that there needs to be a clear separation on what, who can access what, right, how things are governed, what all things the users are looking at. Even if they are trying to look at something, these things, certain things shouldn't be shown, right, all of that stuff. So you need to have some kind of a centralized way of managing the whole access part of it. So this is the the third challenge that is there, that is delivery of your data to everyone, and how the data should be delivered, what sort of rules are there that should be followed, and how will you, make sure that these rules are enforced at all times across your applications. So yeah, so when you hit a search query on Google, right, obviously what's happening is it is hitting some sort of a knowledge graph that is there. It's doing some optimizations and giving you the result. So obviously this knowledge graph building, this activity is a continuous process. So it needs to navigate the websites, get the data from those websites. Then it also has to check if, this data, this information is updated. And then again, what it basically does, it has to update several indexes that are there. So there is a lot of what we say data engineering work that goes on before you can even present an interface that looks like this, and that allows you to simply search and get some results. So if you're looking at the data engineering process, it comes down to something like this. What you see there in the red is analyze, right, the third part. That's where you can, potentially write your SQL queries. But this goes from, the whole thing goes from left to right. That is, before you even get your data in a form where you can analyze it, you will have to first start ingesting, or capturing the data. When you ingest the real world data, some of the common problems that you can face are things like duplicate data, so invalid formats, right, and lots of different kinds of missing values. So you get the picture. The data needs to be processed or transformed in a way so that the relationships or even logic that is there in underlying inside the data can be detected. And at the end of it, as I mentioned, it cannot be just a single thing. Again, you need to get the data out also, right, to maybe machine learning models, like you could export it simply to, so like utilities like Google Sheets, or you could have it uploaded on TensorFlow. So this brings us to this highly complicated technology stack that you can see in this figure. So under each of these four steps of data engineering, there are various tools or services that Google Cloud provides. So we don't have to go into each one of these services at this point, but you will get a high level picture. You might not use all of them together, right? So maybe just use one or two. Even as you perform the labs, you will notice that you will not be using most of them. However, you will get a quick start, sort of a lab. So you could have pubs up, quick the publish and subscribe, the quick start lab. Then you could have data proc quick start. So just to introduce you to how, what it is and how it operates, and what kind of the task it performs under data engineering. So if you want to ingest data, so maybe you can use PubSub, right, to dump all the files, and then you can use data flow, for example. So if the files come in, then you have to process them. You have to do something called as data sanitization. Okay, then you need to remove the duplicates, the redundancies that exist, and fill out the missing value. So when all of that thing looks fine, then what you can do is you can store it in a BigQuery, a tool like BigQuery that is used for analytics. So once it's in BigQuery, then you can employ your analysis team, your data analysts basically, to work on that data. So once that is done, then you can export it to platforms for you, such as Google Sheets or TensorFlow, or the Google Data Studio that is there for visualization, right, and even business intelligence tools that are there. So this is how it comes together eventually. The organizations will suddenly say like, I would like to use generative AI, but that comes in the fourth step, right? But have they done the first three steps is the question here. So if you're not done the first three steps, then how are you going to get the data in the first place? The data needs to be in some way that makes sense, right, to work with. The entire data process, the data engineering process, it cannot be avoided if you want to use something like generative AI, or auto ML, or use of vertex AI and all these sort of things. You need to have a strong process or a strong system in place, so that your data is ready to generate the right results. So for the purpose of having, for the data analytics purpose, of having like this tool for analysis, what Google Cloud, from Google's cloud's perspective, what you have is called as a BigQuery. So it is really, the core, whether it's a volume, your variety, your velocity, or, your reach, or the workloads that are there. So Google has this one-stop solution called known as a BigQuery. You can see there is three important attributes to it, right? First is limitless data, then comes the limitless reach, and then the limitless workloads. So to begin with limitless data, there are several kinds of data connectors, whether it's the HTTP request that you're talking about, right? The HTTP requests that are coming in, or some any other popular third party systems. So you have this, I think Google supports about 200 of these data connectors from different third party and open sources. You have data connectors from like Salesforce, Slack, all these technologies that are there, all these companies that are there. You have data connectors, so that will basically provide you with a serverless kind of approach of getting in the data, right? And to work with loads of data. So, and to achieve the workloads, basically, as you can see here, the BigQuery has support for SQL like constructs, right? And it also has a built-in AI ML, right? So you can simply work around with the data and using BigQuery, and then you can even generate models from within BigQuery. Although they won't be very, they might not be so sophisticated, but it will get the job done. So this will help you build models from within BigQuery itself. So this is also one of the new and popular feature of BigQuery. And finally, in order to enhance the reach, there is the built-in business intelligence tool. So many of us have heard about Power BI, Tableau, and so on. But even in Google Cloud, there is a built-in BI tool as well. Or you also have the Data Studio for visualizations. So among other things, or you could otherwise depending on your needs, you could simply export your results onto some spreadsheet, and then from there you can carry on, right? So although so this is how things are in terms of data engineering. And although means I still have to finish this rest of the puzzle, but I hope you get a clear understanding of why data engineering is required in the first place, right? And only then you can understand how the different tools work, right? So let's begin with AI services now. So within AI services, as you probably know to some extent, we don't necessarily have to be an expert in AI, right? Obviously, the more of it that we know, it's better. But it's not something like you have to have a very strong data science or a very strong ML-based portfolio to simply work with these AI services. Simply to use this, to leverage the AI services, right? Rather than building them or something like that. So let's look at this spectrum. Yeah, just like how we have the compute spectrum that we've seen previously in other sessions, the whole democratization, like part which is involved, is based on the levels of the needs, right? So you have the on one side you have the pre-trained APIs, like Vision API, Video Analysis API, or the other models that are already in place on Google Cloud that you can use. And on the other extreme, we've got the core tools. So if you're familiar and well versed with AI and data science, then you have Jupyter notebooks, you have got TensorFlow, the GPUs, TPUs, and all the other schemes that are there. You can continue doing that as well, right? So it depends upon where you are, what position you are currently in, and how you want to work with these AI services. And finally, in the middle, we have high level constructs like custom AI, BigQuery ML, and Auto ML. So These are like, you just give it your data and you can use these services. So they are basically like a common ground between these very core tools and the pre-trained models that are there. So for example, auto ml, it will simply, you can just give it your image data, and then you can tell it what all it is about by giving some kind of labels, right? And then it will build a model for you. So you don't have to necessarily be a data science expert to do these things. So it depends on where you are, right? So many organizations, they want to solve a problem using AI, but they may not have the skill set to do it. So this is why we need these spectrums to try and find how we can cater to the situations of these organizations, right? So now if you look at the Google Cloud's Gen AI portfolio, so beginning from the bottom, obviously, is the infrastructure. There has to be obviously the storage, the VMs, the networking, the GPUs, TPUs, and all the other specialized processing units that are there. But as you move higher, there is this whole Vertex AI suite, right? So Google provides their own foundational models, or it brings in partner models from and the open source models that are there. So that basically comprises of what is known as the model garden, right? So think of it as like a catalog of what all there is in Vertex AI. And as you move higher, you will find that you can start creating solutions using these models. So, and at the same time, you also require a platform that allows you to tune these models, analyze them, or host them, and so on. So what you can see on top of that is the applications that you can build, right? So for example, Vertex AI search, right? That works with cloud storage mainly, and even BigQuery. And you have the conversational solutions, like it involves using services like the Dialogflow, right? The APIs and the other chat based solutions that are there, right? So using these different offerings, you could have the different kinds of AI based solutions that you can create. And yeah, so you could leverage the different types of models that Google has its own native models from the model garden. And then you could maybe fine tune them using the Vertex AI platform that you have. And then maybe after fine tuning them, you can convert them into some kind of a solution of some kind of personalized solutions that you want to create. So this is how the generative AI portfolio looks like. So you might have noticed that most of these were all managed services. So with all these managed services, ranging from databases to data engineering, AI, and all these delivery solutions that are there, we kind of have a unified data and AI platform. So in the middle, you can see Google's data cloud, right? So hopefully, the different steps are understandable to you by now. So the first is the data engineering part. In the data engineering part, you have things like tasks like getting the data, ingesting it, cleaning and transforming it, right? And so on and so forth. And then of course, in the way it is put under for analysis is you have the BigQuery, which is like the one stop solution, like I mentioned, right? So you might start doing some sort of moderate. Then after after analyzing or conducting your explorations through BigQuery, then you can start working on developing and engineering your solution using things like Vertex AI. And obviously after that, you have the activation, right? So insights activation. So you can get, once your model, the custom model is ready, then you can visualize it in terms of some curves using the Google Studio, the Cloud Studio. And or you can even integrate into other applications using tools like Cloud Run, so that those applications then can query your model, and then they can work with the model, right? So now start seeing the left and the right sides of this figure. So your data could basically come in from anywhere. So as I mentioned, there are so many connectors out there, or you can write your own integrations as well. And it could be coming from various e-commerce systems. It could be coming from various sensors, devices, whatnot, right? And even from other clouds as well. And then you have the things like social medias, right? You have the operations related to genome sequencing and all. This produce data at a very high velocity. So you need to this is how the data basically, it says on top, any data, right? So it should be, your system should be able to work with any kind of variety, any amount of volume of the data that is there. And similarly, you need to take the results out as well, right? It cannot be sort of a silo, or like a closed environment that is there just for exploratory, exploratory purposes. Or even after creating the model, it shouldn't be just like just running the models through some sort of a platform. But you need to integrate it with the existing solutions that are there in the market. So it's basically titled as any innovation, right? So it basically so that your model is able to drive the applications of today. So you can see things like app development, SaaS applications, right? Operational intelligence, all these things, and it's a decision making at the very top. So basically, this is what is needed from this Google's data cloud. This was the purpose why it's there in the first place. So now on the top, finally, you have the different roles played throughout this entire life cycle, including even the end users. So you have developers. They might say like, I'm writing an application to use these models. And similarly, you have data analysts who might say, I want to use a BigQuery to perform some explorations, right? And then you have the ML engineers and the data scientists who can possibly be working across the different data engineering tasks, like more, even across the model development layers that are there. So hopefully, this short ride from the start, the different databases that we spoke of. Then we talked about the problem organizations are facing, the analytics, with BigQuery, and finally we combined it in sort of a comprehensive way, right? So this is how it is in the real world, guys. So the whole modeling part will be a failure, right? If you don't have a process or a workflow in place, right? Or a way by which you can do this activity in a structured fashion. So the tools, whether it's Google Cloud, another some other cloud, any other cloud that is there, you will figure out the tools eventually. So the conceptual things, are there that are there is what you have to get right, so that you can make the right trade-offs, the right decisions. So this is how the unified platform is. So yeah. And yeah, with that, basically that was the only part remaining from the course that I had to cover. And so that's all I had for the session today in terms of the concepts. Okay, so next we will see the objectives for this week. So you can start with activity 4, which will provide you, it's based on data, ML, and AI in Google Cloud. So it will provide you some informative videos, right? And there are a few labs as well. And then you can begin with activity 8, which is again based on the same topic, that is data, ML, AI tasks and all, and which is basically purely labs, right? It's a quest based activity. So you can start with activity 4, and once you're done with activity 4, you can begin with activity 8. Some of the labs are also overlapping, so there's actually a very few labs that you have to do under activity 8 once you complete activity 4. So yeah, and with that, I want to wrap up, but I have something else to present to you. Let me just switch sharing the presentation. Okay. Okay, so there's this guide that we've prepared for you for completing the GCA SJ course, and I think this was shared about on, I think, on 21st or the 20th of October through Discord and over on the WhatsApp community as well. So this is how the badges look like. So so there are 8 activities like we mentioned in the GCCF course, and then there's one single activity under Arcade, right? The generative AI game that is there. So once you complete each of these activities, you basically get these badges, right? So once you complete a lab, just make sure you navigate to your profile section, and then you can see these badges that are there, and also the arcade game badge that is there. And this is how the certification of completion would look like once you complete the course. It will be issued by the PCC GDSC club, that's there, by our chapter. And these are some of the rewards that are there. So the learning obviously is there, you get the badges, you get a certificate of completions. And even if if we are able to complete the milestones that are there, then we are also we have a chance of getting the swags that are there for different tiers that that is set by GDS India. Once again, this is the extensions that we had shared on 21st. So these are the extended deadlines. So I think Gen AI is already out. You can maybe you could still try if you haven't. Just try it out. And although its deadline is supposed to be on 25th, and GCCF pathway is on 27th. So in case you've still not redeemed, you can just go ahead and try that. and get started with the labs. So here's a in this guide basically we had presented a sort of like a walkthrough of how you could complete the labs in just 7 days, right? So many of us have been busy with our academics, and it's difficult to manage time with this program, which is quite there's lots of labs that basically that are there that you have to complete. So here's this shortened guide that is there that allows you to complete the entire course in just 7 days. But now you could maybe put in a little more effort and try to get it done within 3 to 4 days. Or even if you have completed some portion of the course, you could follow this guide to complete the rest of the labs that are pending, right? So so basically, day one would be Gen AI, because Gen AI in general is not a pathway which consists of multiple activities. Rather, it's one single activities with just 8 to 9 labs that are there. So you can begin your day one with Gen AI, and you could even instead of day two, you could try to complete Gen AI within day one itself, because the things like generative AI with Vertex AI, the prompt design, the getting started with the notebooks, these things are quite easy to execute. You could get a lab done within 2 to 3 minutes as well. And we've shared different levels of resources with you guys. So we've shared the very comprehensive and the console based way of executing these labs, and then we've also shared a slightly more faster way using the command shells, so you can execute the commands and get your labs done through that way as well. So in day one you could basically try to get complete Gen AI, and then you will end up getting the Gen AI badge, right? You could also verify your status on the leaderboard like I mentioned. And then you have day three, so you can start with GCCF. So for day three, you can begin with the basic labs. So these labs are very basic. It's a foundation, the fundamentals that are there of cloud computing. So what a virtual machine is, what App Engine does in Google Cloud, what cloud functions are, what is FAS, and you could get these labs done very quickly. So I'll be honest, these labs are not very lengthy. Also, you could get it done relatively faster. So and then again, all these quick start labs that you see basically, if it's cloud storage, whether it's Kubernetes, or all of these things that you see that are quick start are very short labs basically. So you can get them done within a few minutes. So maybe you can try to get a day three and day four done on day two. And on day three you could start with the relatively complex labs that are there. These are related to networking. As you can see, you have topics like VPCs, virtual private clouds, right? You have the load balancers, the identity access management, right? So although these are lengthy, but they are quite easy to understand. So and you do not basically get many errors or anything sort like like that. So you could maybe use day three and cover these things, right? And then there are more in terms of generative AI and ML things that are relevant to what we cover today. So services like data prop, data flow, all these are again quick starts, so you can get them done very easily. And you can see it's basically these three labs are all these two labs are all about data prop. One is understanding how to work with data prop using the console, and the other is with the CLI that is there, right? And then you also have the data flow, right, using templates, Python, and also the console that is there. So maybe you can use your final day on using completing these AI related topics that are there. These are basically from activity 7, activity 4, and activity 8. So yeah, so you could maybe use your day 4 to get these two basically sets of labs are done, right? And we've always been we've kept sharing the sessions as we upload them. So you have access to all the previous 3 sessions. We've shared it on Discord, we've shared it on the WhatsApp groups, right? The community that is there, as well as these presentations that I use in the session. So even through these the presentation, these PPT ones we share, you can access these links from here as well. In case you have not joined the Discord link, the Discord server that is there, so you could use the Discord link and just quickly jump in right into the server. And then if you have any doubts, if there are any technical glitches while performing the labs, then you can always reach out to us, right? And apart from that, walkthroughs have been shared on Google Drive. We'll also be sharing like a collective playlist of all these the collective links to each of these walkthroughs very soon, right? And you could also track the progress on through the leaderboard that is there. So you can basically go access this leaderboard and see how many courses you have completed, how many activities you have completed, whether you've completed the Gen AI or not, what your redemption status is. So you can track all your progress through the leaderboard. So if you have not already started, you may feel like 4 to 5 days is too short to complete such a vast program. But if you do it following guides like these and with all the resources, you should be able to get it done, right? And the team here is also very cooperative. You could reach out to any of us at at any time. So make sure you don't miss these opportunities. Normally these activities, these courses that are there are paid, right? So the study gems program is basically a way to complete and get the badges for these paid courses, right? So you can start your journey, and try to complete the sessions, try to get the swags, the certificates and all of that, right? So yeah, so if you have any questions, if you want to say anything, any comments, and if you want to ask, just feel free, right? Type it in the chat, so yeah, I'll just wait for a few minutes if in case you guys have any sort of doubts regarding the program, regarding the concepts, and maybe then we can wrap up.